Good morning, everybody. This is Kevin Renaud with Peerless. Thank you for joining us. We are going to get started here in just 1 minute. There's still some people filing in, so we're just going to give them another few seconds here before we begin. All right, we're going to go ahead and get started. Again, my name is Kevin Renaud with Peerless. Today we have our friends from OPW with us to talk about loading and unloading operations within the plant, specifically efficiency, reliability, and safety. So today we always start with the geography, just so we know where we're all calling from. Today our geography includes folks in New York, Pennsylvania, Ohio, Maryland, North Carolina, Missouri, and Colorado. Not going to kid you, it was a bit of a geography test this morning for me while I put the stars on the map. In the industries we have today are chemical plants, manufacturing facilities, engineering EPCs, and some mechanical contractors. If you've joined us before for some of our past sessions, you may have heard this before, but again, our customers rely on us for process components to keep plants operating efficiently and projects running smoothly. Our customer base is diverse, skilled, and highly complex. Can I ask you to go on mute, someone that's a panelist? Thank you. Our customer base, again, is diverse, skilled, and highly complex. We do have 3 divisions. Our Procore segment, we deal with OEM customers, skid builders, packagers, EPCs, and engineers. Our process division, which is highly focused today in today's discussion, our chemical plants, pharmaceutical contractor, food and beverage, manufacturing, and universities. And finally, our high temp division, where we work with high temp insulation, refractory, scientific surfaces, and laboratory and medical companies. So today, this morning, we do have David Morrow with OPW. He's the Director of Product Development. He is based out of Cincinnati, Ohio, where their headquarters is. Also, Bill Burns is joining us. He's the Regional Manager for OPW. We're fortunate to have Bill working right here in our area. He lives in Buffalo, so he's always just an arm's length away when we need him involved. And from the Peerless side of things, we have Dan Morgan. He's our continuous improvement manager, and he will be moderating. I'll be turning over to him for some housekeeping notes in just a second. Greg Barrell, he is business development for our process division, and me, Kevin Renaud, again, I'm in business development. So we do like to give it's been customary to give a little bit of a unique perspective on our presenter today. So Dave Morrow, I did learn that he is actually a marathon finisher. So congratulations to Dave. And I started thinking about it. Let me tell you, he did not compete in the 20 to 25-year-old group. So I started wondering how a guy like that's able to do it. And it occurred to me that he is a Bengals fan. So he's probably run out of more stadiums than any football fan out there, and that's coming from us Bills fans. So that's likely where he got his stamina and his speed, and I was fortunate enough to find a picture of him as well. So I just thought I'd throw a picture of Dave Morrow and his glory there at the Bengals.
I love it.
So with that said, I am going to turn it over to Dan Morgan here briefly, and we'll get started. Again, thanks for joining us.
Yeah, hey everybody. Thanks for joining us today. I'm Dan. So what I'll be doing here today is keeping an eye on things in the question panel. So throughout Dave's presentation, if anything catches your eye or you're looking for a little more clarity, or maybe have an application specific question you might want to ask of Dave, please feel free to submit your questions through that panel right there. And I will be asking Dave at different points for that presentation, possibly answering it myself, or potentially following up with you after the webinar to provide you with a further answer on that question. So yeah, please feel free to submit them at any point. And with that, I will now turn this over to Dave.
Okay, guys, good morning. Everybody hear me?
Yes, we can hear you. Cannot see your screen yet though, Dave.
Okay. Can you see that?
No, it's asking me, Bill Burns, to share his screen where.
Okay. Okay, one sec.
There we
Hold
go.
on now, Dave. All right. Perfect.
Okay, can we see now?
Yes, good to go.
Okay. Great, guys. Thanks for joining us this morning. Thanks, Kevin, for that great intro. And yeah, I've ran out of quite a few stadiums in my day, so appreciate that. First of all, I want to thank everybody for attending today's session. Virtually, obviously interesting times in the world, and we appreciate you taking some time to be with us this morning. I want to thank Peerless. Peerless is one of our longtime distributors. OPW excels exclusively through distribution, and our relationship with Peerless goes back several generations. So one of our best partners. So thanks to the Peerless team. Let's see, how do I advance? My slides are not advancing.
Click on the screen first, Dave. Try that.
Okay. There we go. Okay. So I was trying to use the pointer, and apparently if I use the pointer, it's hard to advance. So let's jump right in. So the goal of today really is to give a better understanding of loading arms, kind of what we do. Hopefully some things that you can use with existing equipment or things to think about on future projects. Kind of the who, what, when, where, why of loading arms. So we'll go through lots of pictures, application examples, kind of go through design considerations, things that we go through in the process that we use to design a system. And then we'll end today's session with just some common issues, kind of a troubleshooting guide, if you will. Again, things that you might be able to take back to your current situation to make something that you have in place better, or something to think about on a future project. So just a quick review of OPW and what we do. Really, our business is about moving bulk fluids. So if you're moving bulk liquids into a tank truck or a rail car, we make the equipment to help you do that. What most people know us for is the loading arm. So we make the equipment to load and unload tank trucks and rail cars. Also sell a lot of swivel joints. Swivel joints are the main component of the loading arm, but we also use them in a lot of different applications where you need to add flexibility, hose reels, large diameter hoses, manifolds, things like that. The other big part of our business is connections. So we make a lot of different connections that are used throughout the movement of bulk chemicals. From a quick connect, just a simple cam and groove fitting, the cam lock. I'm sure you're familiar with a cam lock connection. The cam lock was invented by OPW many, many years ago. Lots of people make them today, but we kind of invented that, and we have a whole host of different connections depending on the different fluid that you might be handling. So in summary, if you're moving bulk fluids or handling bulk fluids, we make the equipment to help you do that. That's what we do. But today's session is really going to focus on loading arms. So let's jump right in. So for loading arms, what are we trying to do? It's really a pretty simple thing, and we're moving product from point A which is your product piping, what we would call the riser, where you're going to connect the arm to point B. The point B is the transport. So we're just moving product from point A, your piping, to point B, which is the transport, which could be a truck, a rail car, a drum, or a tote. Sounds simple. But there's lots of issues that we have to deal with. You know, we say we move bulk fluids. Those fluids can be anything. It could be anything from wastewater to petroleum to crude oil to acids to whiskey or chocolate. So, you know, what are the hazards of the different products that you could be handling? There's ergonomic issues. So if you have couplings and valves and different things that you're going to need to make that connection, how do you safely handle those things? How do you make it ergonomic for your operators? The logistics and storage issues. If you look at a loading rack or any loading situation, the piping is always different. So the piping could be coming from below, it could be coming from above, it could be coming from the side, it could be on the right side or the left side of the platform. There's issues with the transport. So the trucks could be different. You could have a truck that comes in one day, the next day it could be an isotainer. The rail cars, there could be a lot of variation with the rail cars. So there's lots of variation on the transport side. Then you have the access and safety equipment, the gangways, the safety cages, handrails, piping, other loading arms, I-beams, canopies, lighting. The list goes on and on of things that could interfere with the loading arm. And then finally, compatibility. You know, any fluid, so making sure that the components of the loading arm are compatible with the product that we're handling. So if you put all that together, each loading spot or each loading arm is kind of like a snowflake. So they're each different in their own way. And the name of our division of OPW is Engineered Systems, and that's really where the engineered part comes from, is working with our customers to engineer that solution that's going to fit for you. So that's what we do. So back in the day, it all started with hose. Everybody uses hose to load their transports, and it's slowly evolved to where most people are using loading arms, and we'll talk about some of the differences and reasons why people would choose a loading arm over hose. So what is a loading arm? So if you go to a party and try to explain what we do, they glaze over pretty quick when you try to explain loading arms. The easiest way to explain it for me is to think about this. It's really a glorified gas nozzle, and another division of OPW is big in the retail space. So if you look at the nozzle when you put gas in your car, it probably says OPW on it. And what we do, instead of putting fluid into a gas tank, we're putting fluid into a tank, truck, or a rail car. So it's a glorified gas nozzle. So that consists of piping, swivel joints that give us the flexibility, a counterbalance, and the counterbalance is going to be sized to carry the different components that are needed on that arm. And then there's a whole list of accessories that we'll look at that could be incorporated into the arm. But that, in its simplest form, is what a loading arm is. It's pipe, swivel joints, a counterbalance, and accessories. So within the loading arm itself, there's different components that we can use. So within the swivel joint, there are different types of swivels that could be used, from a very simple design, and usually it's dictated on by the product and the hazards of the product, determine which type of swivel that we would use. The piping would typically be dictated by the material that we're handling. So it could be carbon steel piping, could be stainless steel piping, could be aluminum, depending on the product. The counterbalance that we use, we have different types and styles. Again, that is engineered to fit with whatever components and accessories and reaches and That drives what that looks like, even up to pneumatics. So it's just a push button up and down operation. And then accessories, and we'll look closer at the accessories that we commonly deal with here as we go through the presentation. So why would you use a loading arm? And again, back in the day, everybody loaded with hose, and still lots of people use hose. We'll use hoses on loading arms occasionally, but the primary reason that loading arms really came into favor with chemical transports was thinking about the mode of failure. So when a hose fails, it usually would fail catastrophically, so it's going to burst. There may not be any warning. It just gets to a point where it's fatigued, it's worn, and it could be a pretty catastrophic event. With a loading arm or a swivel joint, a swivel will also fail eventually. It has a seal inside that's going to wear, but when it does, it's a much more contained event. So a lot of times what you'll see is the swivel will just get wet, maybe drip, but it's much more of a contained situation. So most people, they look at loading arms as the preferred method, especially as the product becomes more hazardous. So the more hazards, the more lethal the product might be, the more loading arms make sense. So the other big reason for loading arms is the safety and ergonomics. So you see the picture here. We have a pretty big loading arm. This is a crude rail car loading arm. Now it's probably a 17 or 18 foot long reach to get out to the car. It's got a long drop tube. They wanted submerged loading to minimize foaming. They wanted a cover plate to keep it all closed off. And it's kind of hard to see here in the picture, but there's also overfill, a level probe that's on this. So all that's designed into the arm. And we got a little 5'8" operator here that's able to easily walk this arm out and put it into the car. So the ergonomics are a big thing. It's counterbalanced, very easy to operate. A single operator typically is the goal, like you see here. Again, lots of accessories, and we'll get more into accessories, but vapor recovery, very common option where they want to cover off the opening. You know, a lot of times the arm will be designed to carry both the product and the vapor. We want to do overfill in many cases where if you do close off that opening, you're not going to be able to see the level. So we'll put level detection. We'll build that into the arm. Valves and couplings are also very common accessories. So what you see here in this picture is a pretty typical rail unloading situation. Most rail cars are top loaded, but they're still pretty commonly bottom unloaded. And when they do bottom unload, they use hoses. So you can see situations like this where you just use long 20-foot sections of hose to plug up underneath the car. So it's quite a mess. So you got big, heavy, long hoses that are on the ground, you know, in the winter. You know, so you could have snow and rain, and you know, a mess you're dealing with, and you got to climb underneath the car to make the connection. So you replace that with a loading arm. Yeah, basically it swings out like a gate. It's all self-supported, and you plug it in. Another reason for loading arms would be speed, efficiency. People generally want to load quicker and faster. So doing more 4-inch arms, more 6-inch arms, that would lend themselves more to an arm. So much quicker, faster, and if you incorporate all the connections to make the connections into the arm, it's just going to be much quicker connection. So you can get those cars in and out quicker. So just looking at adding a little bit more color about design. things that we look at. We talked about ergonomics and safety. Also think about the riser, the piping that we're going to connect to in your plant. Sometimes that's located in a difficult spot. So a loading arm can improve that situation. If you have a difficult hookup, so the connection to the transport could involve valving, excess flow valves, a quick connect or a dry disconnect. That can all be incorporated into the loading arm to make those components easy to carry for the operator and make that connection easier. The product itself is an important consideration. So what is the fluid? And again, generally, the more hazardous the product, the more loading arms make sense. So some other advantages of looking at a loading arm versus hose. Obviously a hard pipe system versus a hose, and in a lot of situations makes a lot of sense. A loading arm being hard pipe is going to last much longer. Generally, the life of a loading arm we measure in decades, not years, like you would for a hose. And with hoses, and again, hoses are used in a lot of loading situations, but there's pretty strenuous, or there can be pretty strenuous testing requirements that apply to hoses. So they might have to test them quarterly or annually to make sure that they're okay for that service. For the loading arm, generally those testing requirements aren't required. So ease of operation, efficiency, obviously lead to a loading arm. The safety and ergonomics we talked about. And if you look at the overall cost of ownership, again, loading arms in general, we measure them in decades. There's arms out there that are 20, 30 years old that we get phone calls on all the time that are still up and running. So many, many years of service. So a disadvantage could be cost, the initial cost. But again, if you look at the overall cost, the loading arm quickly makes a lot of sense. And then support piping, we got to think about loading arms are heavy. So we got to make sure the piping that we're going to tie into is structurally sound and able to handle the weight of the arm. So we'll talk a little bit more about support piping later. And mode of failure, we covered that earlier as well. So in summary, just to kind of button that up, why loading arms? The safety, ergonomics, speed, efficiency, overall cost of ownership, very long life, easier maintenance. You don't have the testing requirements that apply to most hoses that are used for loading. And just a little more color on design of kind of things that we think about, when we're doing an application. Safety is always number one. What we like to do when we look at an installation, it's really walking through the entire process of loading. So when I say the entire process, I talk about, from when the arm is stored, back on the platform, how the operator is going to get that arm that's stored, and then walk out and access the truck or the rail car. How does he get the arm? How does he walk out? How does he make the connection, do the load, and then walk back and put everything stored? And one of the big mistakes we see with arms is they kind of design it around everything being connected. And the reach is right. They have a lot of the right components, but then when the arm goes to store, it's in a bad location where the operator can't get it. It's just not accessible, or it's in a place where he's got to stretch or reach. He's got to use a rope or a chain to get the arm. Things that we try to avoid. And if we walk through that process of how do you get it, how do you deploy it, we're going to size the arm so that it's easy to access. So putting the right arm in the right location. So are the reaches right? So the thing to think about with the reaches, again, a common mistake is they might look at what the reaches are required for a certain type of truck. But 2 days later, a different truck may come that has a different connection, different orientation, that could change the reach. You know, one day they might load trucks at a spot, the next day they could load isotainers at a spot that are 3 foot shorter. So the arm that works for the trucks may not work for the isotainers. So it's really thinking about, you know, kind of best case, worst case, and what situations are we going to have to cover at a spot. You know, getting the pipe sizes right, the materials of construction right. You know, that usually it's going to be driven by what is the fluid. Generally, we're going to use carbon steel, aluminum, or stainless steel. We do some of the more exotic alloys, and then the seals that we use. So a whole host of different seals, depending on the fluid. You know, Buna, fluorocarbon or Viton, Teflon, neoprene, EPT, FFKM. You know, the CalRes, ChemRes. It's finding the right materials for your application. And temperature is another one. You know, we could have the right seal that works great in the summer, but it may not work so well in the winter. So we got to think about the location of where we're at, making sure the seal is going to hold up to the temperatures that we're going to see. Obstructions. So obstructions are a big deal. You know, they could be the handrails, the safety cages, I-beams, supports, lighting, pipe racks, other loading arms that could be on the platform. So there's all kinds of things that could get in the way, and we really need to think through, you know, anything that could interfere with the arm. And then accessories, there's a whole list of different accessories, the valves, the overfill. Do we need to do vapor recovery, heating, insulation, grounding, safety breakaways, and then couplings and connections. And we'll take a closer look at some of these later. So just a good example of a loading arm. You know, this a big arm cover plate. You can see the overfill sensor incorporated into the arm. You know, and the cover plate sealing everything off. So pretty typical. So this is our design form for top loading. So it kind of shows you what the process might look like when we look at an application. It really starts with this. And what we're trying to do is find our point A, which is your piping, and the point B, which is the transport. So where is point A? Where is point B? And what is around us? So the handrails, the safety cages, the gangway to get out on the transport. It's really trying to understand where all of those things are, and then we'll go through and design an arm to fit that. But it all starts with the design form. So methods of loading. So most of what we do is top loaded today, but we do some bottom loading as well. You can see some of the most common top loaded products. You know, butadiene, benzene, acid styrene. Generally, the more hazardous the product, it's going to be top loaded. Bottom loading is primarily for fuels. So all the gas, diesel, that's goes to the service stations. All that is bottom loaded, and LPG and anhydrous would be the two non-fuel products that are bottom loaded. And then, as I mentioned earlier, most rail cars are still unloaded through the bottom. So if we look closer at top loading, so different methods of top loading, the most simple would be just an open dome. So they flip the lid. So the rail car tank truck comes in, they flip the hatch, pull out a loading arm, and let her rip. So that's what that looks like. Super simple. The other method for top loading would be we're going to make a tight connection. So there's valves on the car that we would tie into, and we'll have the mating adapter or the mating couplers on the arms to make the connection. So you see here, we've got a product connection with a camber lock and a vapor connection with the camber lock. So we're going to plug in and make a tight connection. Different types of top loading arms. We don't want to get too much into the weeds here. Just, I think the important thing to think about is different arms do different things, and really we think about how much reach do we need to get from your piping out to the car, and how much flexibility do we need. You know, how much variation is there, misspotting is there? And the more reach and more flexibility or misspotting that we need, the more it's going to lean toward, you know, these boom type arms. So the boom arm that you see here on the right is by far the most common arm design that we use for top loading for those reasons. Gives us lots of reach, lots of flexibility. So some pictures just to kind of give you some ideas. I mean, here's some top loading spots. Looks like in both of these situations, piping is going to be coming in from the top. So top loading, but as I mentioned earlier, I mean, the piping could be from above, it could be from below, it could be coming in from the side, could be on the right, could be on the left. So all those things go into what that arm needs to look like. Now here's an LP gas rail loading situation. So this is, looks like there's two product connections and a single vapor connection here. You know, 3 independent arms. Here's another LP gas rail spot where they're making the 2 product connections to the car, like you see here, but it's a single arm. So a single arm that we tee off to make 2 independent connections. So we call this a bullhorn type. So we got this little bullhorn at the end that branches off to make both connections. And then finally, another look at a rail or an LP gas rail loading situation where we've got, again, 2 independent arms. Really good picture, kind of showing kind of ideal scenario of what we try to do with every application that we look at. The arms are going to fold up and store. The operator can easily access the arm, you know, right there, you know, at the gangway, and then he can walk the arms out to make the connection. And when he's done, looks like he's done loading. He's walking these arms back to the stored position. He's just going to walk back down the gangway and put them into the stored position. So a beautiful look at what we try to do with every install. Easy to get, easy to deploy the arms, easy to store the arm, very accessible. And that's what we're always trying to do. So a lot of times on these platforms, we could have lots of obstructions, lots of things that could interfere with the arm. And you kind of see my little shoehorn reference. You know, we feel like we've got to shoehorn the arm, you know, into a very tight space. So understanding where all the components are on a platform, you know, whether it's lighting, I-beams, meters, piping, other loading arms, the access equipment, you know, all of that stuff we have to understand where it is so we can design around it so it's not going to be a problem. We also have situations where they need to use hose, or they're going to use hose. And normally this would be a situation when it's a highly corrosive product like an acid, where you could not use a metal swivel joint, where they need to use a Teflon line piping, Teflon line hose, or it could be in a food situation where they want food grade. So we would do what we call a bypass arm. So we use the loading arm to support Teflon line piping or food grade components. So you get the benefit of a loading arm, being self-supported, being ergonomic without actually using the loading arm to transfer the product. So we call that a bypass style arm. And this is what that might look like. So this is an acid arm. So it's Teflon lined piping, Teflon lined hoses, both a product and a vapor line. So we're not transferring the product through the arm. It's going to go through the Teflon line components. So you get the benefits of the arm without actually using the arm. So it's kind of like a hose handler type situation. The arm kicks out and very easily makes connection, and you plug in, do your load, and just fold it back up. And very, very clean and easy way to do it. So bottom loading. So again, bottom loading is primarily for loading fuels. So all the gas, diesel, jet fuels would be bottom loaded. And that's what you see here is a bottom loading petroleum application where they plug into the belly of the truck. The other common thing would be bottom unloading rail cars. So we've got kind of a low profile arm that you see here that can get down low and kind of tuck up underneath the car to make the connection. The other common bottom loading application would be LP gas and anhydrous. So this is kind of the go-to style of arm for those situations. So we call it an A-frame. So it stores kind of upright, more vertical. And then when they load, they just kind of unfold it and plug it in, like you see here. So let's kind of run through some specialty applications that we deal with that are pretty common. Vapor recovery. Again, dealing with hazardous products, recovering the vapors and keeping the emissions out of the air, very important. So we do a lot of vapor recovery situations. There's a lot of products that require heat. It could be for just freeze protection, but there's a lot of products that if you don't keep them heated, they just won't flow. I mean, they'll solidify. So we can do that within the loading arm, either with electric or steam. And if you heat it, you probably need to think about insulating it. So we want to keep the heat in the arm. And we also want to protect the operators because it will be hot. So we want to protect the operators. So insulation is something that we look at. Level control, very important. If you're loading at 300 or 400 or 500 gallons a minute, we want to make sure that you don't have an overfill situation. So we'll incorporate level control into the loading arm. And grounding, loading at very high flow rates, it could create a static situation. So making sure that the arm is properly grounded and that you're monitoring grounding. And we can do some things with electronic grounding to make sure and give you some electronic verification that, hey, I am grounded, it's okay to load. We talked about corrosives, what we can do with that, and drums and totes is something else that we're doing more of. So we'll look a little closer at that here in a minute. So I'll just run through some pictures of some of these specialty applications. So if you have a situation where you want to do vapor recovery through an open dome, there's two ways that we would do that, either with a cone, like you see here on the left, or with a cover plate. And the cover plate designs that we use today are basically like the lid of the transport. So we have cover plates that kind of match up the bolt patterns of the trucks and rail cars. So the arm has that plate on it. You drop it into place, and you literally use the bolts from the truck to secure it in place. So a very secure, really good sealing option for loading and doing vapor recovery. So heating, some of the common products that we deal with: sulfur, asphalt, phenol, resins, paraffins, all products that require heat. The different ways that we can heat an arm, and it really depends on how much heat you need. It could be electric, where it's basically a heat blanket. We can do steam channels. We can do fully steam jacketed, where it's almost a loading arm within a loading arm. And again, depending on how much heat you need, that kind of drives what type of heating we would go to. But the other important thing to think about is the insulation. So you see here, these are our heated arms that we've supplied with insulation. It's a really nice package. It's removable, so you can take any piece of this off. And you can see kind of here on the right, the guys in the plant, they're really good at insulating fixed piping. Maybe not so good at insulating a loading arm, which is kind of like a wet noodle. It's got to swivel, it's got to move, and these insulators are good at doing this, but when it gets to be a loading arm and being able to insulate a swivel that needs to move, could be a problem, could hinder the movement of the arm. So we've been doing more of these insulation packages that are custom designed for that specific arm. So all the pieces are removable. So when you need to do maintenance, you can easily take them off, do the maintenance, do the work you need to do, and then put it back on. So a really nice option. So another vapor recovery picture. So what we're doing here is we have an arm that's handling the product. And we're doing what we would call a piggyback scenario for the vapor line. So the loading arm is carrying both the product and the vapor on a single arm. So just swing out the arm, plug in the product, plug in the vapor. A pretty common way to do it. And drums and totes. Most people think loading arms, they think about trucks and rail cars. Not so much about drums and totes. And this is a really good option for those situations where you're loading a pallet, a skid of drums or totes. Generally, these areas can be pretty nasty areas, where they're using a hose. I've seen people that just use gas nozzles to load drums. And if you go to a scenario like this, it's all self-supported, it's counterbalanced. The valve's right out the end of the arm. So really easy for the operator to load multiple drums. Gets the hoses up off the ground. Really nice way to do it. So we're doing a lot more of these types of things. There's another situation. And with what's going on right now with the COVID, there's been a little boom in this area with some of the sanitizers and people making the cleaners and sanitizers and those types of things. Just a nice little skid package. So just want to run through a few examples. I think these do a really nice job of kind of showing you what we try to do. Take kind of a before and after look, at a situation. And what you see here is a hose loading situation of what they were doing before. And when we get into these more difficult situations where we got to make things fit, we got to shoehorn them in, we'll go through and do these models like you see here on the bottom. So we'll show you, like, this is what this is going to look like. So this is a project we're doing right now where we're going to get rid of the hoses and it's going to be replaced with loading arms. So you can see it's going to be a much cleaner, much better operation. And we talked about rail unloading, and you can see, doing the long 20-foot hoses versus doing, a self-supported loading arm situation that kind of swings out like a gate, has all the weight, it's all counterbalanced, and you're just going to plug it in. So much better situation, much easier, cleaner, more ergonomic, safer. So that's what we try to do. This is a picture of a very typical petroleum bottom loading situation. This is a job we just did recently where the operator or the customer, they wanted to create, the problem they had is the trucks came in and they couldn't get the right arm plugged into the right compartment. So they had a lot of problem with crossover. And in a petroleum bottom loading situation, you'll see 4 or 5 of these arms like you see here, because it'll be like at the gas pump, regular gas, mid-grade gas, premium gas, diesel. And when the truck comes in, ideally you want to be able to grab any of the arms, whatever arm you need to plug it into any of the compartments on the truck. And on the left, what they had before, they couldn't do that. They had to duck and dive and move arms out of the way to get an arm on the right to connect to a compartment on the opposite end. So it was really difficult. When we got done, you can kind of see on the right, each of these arms operates completely independent of one another. So you can take any arm, connect it to any compartment on the truck without having to duck and dive and move anything to get it done. So a really nice picture kind of showing you what we did, you know, in the process of, you know, we provided these dog leg risers you see here. So the staggers are all really nice. The spacing in between the arms is really nice to kind of set up the optimal scenario. So a really nice picture. Another scenario of you know, kind of a big ugly here on the left. It's a steam jacketed hose situation, really heavy, you know, hard to move. And on the right, what you see is a steam jacketed loading arm. So like it's kind of a loading arm within a loading arm where the outer loading arm is steam. You can see the steam jumper hoses. Doesn't have the insulation on it yet, but it's all self-supported. You know, would swing out like a gate and then plug into the car. And this kind of shows you another rail unloading, kind of what's going on underneath the belly. You know, tying into the valve underneath the car, plugging in the adapter, and then the arm plugs into that. And again, the drum and tote scenario. So on the left, it's kind of, you know, a hose loading situation. And if you go to one arm, you know, it's all counterbalance supported, you know, much cleaner, nicer, easier for the operator. So it's a good way to do it. So last couple of slides, just wanted to kind of leave you with some of the common issues that we see with customers and with people that are using loading arms. Number one would be rotational drift. And what we mean by rotational drift is a loading arm, when you let it go, it should stay. You know, if you move it out over the car and you let it go, it should stay in that position. And if it wants to always walk away from you, if you're always fighting it, you'll get what we call rotational drift, and it's usually caused by the riser or the piping that the arm is connected to not being properly supported. So we've got a good picture here in a second. I'll show you to demonstrate, kind of show you what that looks like, but a pretty common problem that we see with arms. So, and you can make that situation much better just by properly supporting your piping. The next item is what we call heavy arm syndrome. So again, a properly designed system should be a single person. That little 5'8" guy should be able to lift up the arm and pull the arm down without too much difficulty. If it's really heavy, really hard to work with, something is not right. So the loading arm does have a spring on it. Is the spring properly adjusted? Is it the right spring? You know, there's a lot of situations where people have added weight, added components to the arm that it could require a spring, either a spring adjustment or a different size spring to properly balance the arm. So just looking at that spring could make an arm that's not operating so good, make it much better and much safer for the operator. Product foaming or static, and this really is all about the loading and how product's loaded. You know, if it's falling a long distance, it could create a foaming situation. So longer drop tubes, getting it closer to the bottom of the tank, you know, could really help the situation. The other issue with product falling is static. So thinking about static, you know, getting it deeper into the tank, you know, could help minimize static. So, you know, ground verification, again, that's something that we can help address. And then the last couple items here, thermal expansion. This is a big problem with fuels, especially wherever you have two valves that are closed. If you don't have thermal relief around those valves, it can damage loading valves on loading arms. It could damage the couplers on loading arms, and it could create a pretty bad situation for the arm. So always thinking about any closed loops, do we have proper thermal relief? And then finally, line shock. You know, people loading at very high flow rates. We want to get things closed off slowly so that we don't create problems for the loading equipment. So rotational drift, we talked about that. This is a really good picture, kind of demonstrates what that looks like. So here we've got a really tall riser, or the piping that we're going to connect the arm to. And a loading arm could weigh several hundred pounds. And off of that piping, not only does it weigh several hundred pounds, but we're cantilevering, you know, this device that's, you know, could be 15 or 20 feet long off of that piping. And if it's not properly supported, it's going to tilt, and you're always going to fight that arm. And imagine being out on that truck or rail car in the middle of winter with high winds and snow and having to fight with an arm that doesn't want to stay put. It can be a real safety issue. So making sure your piping is properly supported, square and plumb is what we want, can really make things better. And the last point I wanted to kind of leave you with is something to think about is, you know, this is a scenario that hopefully nobody is experienced personally, but, you know, I'm sure you've seen this at a retail fueling site where somebody's driven off with a nozzle in a car. But you don't see it so much in the industrial setting currently. So, but these things do happen, and you can kind of see here what the result of that could be. If you are making a hard connection to a tank truck or a rail car, and somebody decides to leave while connected, this is what could happen. So one thing that we're doing more of is kind of taking that the retail lead and what's going on in retail fueling, which it's standard now. There could be a day where we're doing this type of thing that you see here, where you're putting safety breakaways within loading arms, becomes more of a standard. So we do a lot of this with LP gas loading. That's what this is here. If you're going to make a hard connection, if that rail car would get pulled out, the safety breakaway that you see here would disconnect. It's valved on both sides, so it would shut off the flow. Be very minimal release, protects the equipment, protects the structure. Everything's safe. So that's something that we're doing more and more of. So something to think about. And that's really it. So any questions?
Yeah, Dave, actually, we don't have any questions right now. So I guess that means you've just done a really good job of covering and explaining everything. But I will remind everyone again, as we wrap up here and as I turn things back over to Kevin, we will be hanging out for another couple of minutes. So again, if there's anything at all on your mind, or you know, that you would like some further explanation on, please do continue to submit those questions. We'll make sure to get your response. And obviously, you're welcome to follow up with us at any time separately after the webinar. So I'll turn this back over to Kevin.
Thanks, Dan. You got my screen?
Yes.
Yep. All right, great. Well, thanks again, everybody, for joining us. I know we did go over just a little bit over our goal of 45 minutes, but I think it's because Dave has that nice Midwestern pace about him, where for me, everything's a race. So, Dave, I appreciate all the information. It was very good stuff. Again, we're here to support you. One of the best benefits is, again, is Bill Burns of OPW here, who we introduced at the front end. He does live in the Buffalo area, and he's been in sales for most of his life, but he's far more comfortable in safety shoes and a hard hat than he is in a boardroom any day. So he's anxious to get out and see any layouts and assist in any best practices that we can help you with. I'll just turn on, their website does have an assortment of very informative videos and information. I'll just leave you with one real quick one just to show an animation of one of their loading arms, the boom style that he had mentioned as being one of their most popular. Again, thank you again for your attendance. We appreciate it. We are getting used to doing these now every Wednesday. Next Wednesday, we will be offering training for magnetic flow meters from Krone. They are one of the leaders from a technical and marketing standpoint. So we're gonna be thrilled to have someone from Krone talking about magnetic flow meters. So once again, we'll leave you with that. Stay safe. We appreciate your attendance. Follow up with any questions should you have them. Bye now.